All right, let's go ahead and get started. So thank you everyone who is joining us today. I'm Caitlin Barnard, Developer and Community Marketing Manager here at Kong. And I would like to welcome you all to today's meetup. We are going to be talking about our latest Kong Gateway 2.1 release with Hisham and Enrique from our core engineering team. So with that, I will hand it over to Hisham to kick us off.
Hi there, can you all hear me?
Yep.
Okay. All right. So let's get started. Well, we're going to talk about our latest release of our open source flagship product, Kong Gateway. We have just released version 2.1, and a lot of work went into that release, and it's packed with features. And I'm going to try to summarize what's new in the release, and Enrique is going to demo like some of them, and we're going to see some of the features live. Well, I'd like to start with a quick year in review. Early, like in January, we released Kong 2.0, which was our latest major release. And since then, we've had like a regular stream of patch release updates. And while as we were working on like bug fixes and improving stability, and in the meantime, we were also busy at work preparing Kong 2.1, which comes with a lot of stuff from basically like all of the year that we've been working on new features so far. So without further ado, let's talk about what's some of the stuff that's in there. One of the main things that we have been working for a long time was to provide not only high performance in Kong, but also predictable performance, right? Because for those of you who know the way that Kong works internally, you can work either with a database or in DB-less mode without a database, or in hybrid mode where the control plane has a database, but the data plane does not. But when especially when you're working on Kong with a database, the key for Kong speed is to have things in memory cache as they run. But when you do reconfigurations, when you change your routes or your services or your plugins or your upstreams and targets, that means that the cache has to be evicted, right? So that the new configuration comes in, right? And in previous versions in Kong 1.x, what would happen is that some unlucky requests would be the ones that would run without the cache, in which we would have to load stuff from the database and then put it in the cache, and all of the other requests would be fast again, right? And so one of the things we have worked on was to avoid these latency spikes, which would be translate into like higher P99 numbers. You know, like your 1% slowest requests would be much slower than all of the other 99% of requests, because like or even the 99.9 of them. Because essentially like these are the ones in which you have like reconfiguration going on. So over in Kong 1.x, we worked on that in making like the router and the plugin iterator engine reconfigure itself as asynchronously. That means in the background and not during request path. So for Kong 2.1, we are coming full circle, and the load balancer is also reconfigured in the background. So now, all of the main data structures that Kong uses to run through the proxy path have asynchronous reconfiguration. So that means that, yes, Kong is just as fast as ever, but the P99 numbers are a lot better, especially if you have like a very dynamic setup in which you are making changes to your upstreams and targets a lot. So I'm going to put like during the presentation a few pointers to like where to find out more, especially in documentation for users who are already like familiar with Kong. So to enable this, like look up in the documentation the new Kong flag worker consistency. This should be called router consistency because it affected only the router, but now it affects the load balancer as well. So now it's called worker consistency. So look that up and start getting better performance. Another of the main highlights that we have for Kong 2.1 are a couple of new gRPC plugins. And Enrique is going to demo them in the second part of this presentation. So we have gRPC Web, which allows you to access services via the gRPC Web protocol, which is the protocol generally used by browsers to access gRPC services. And also gRPC Gateway, which allows you to expose gRPC services via HTTP REST interfaces. So you can put Kong in front of a gRPC service and have it present itself as an HTTP service that can be used by other clients who don't speak gRPC but do speak HTTP, right? So stay tuned, and in the second part of the presentation, we're gonna see that in action. Another one of the highlights is Postgres read-only replica support. So now you can have two configurations of, if you're using a Postgres database, now you can have two configurations of that. Like you have all of your normal Postgres configurations, which are all of these Kong flags that are PG something, like PG host, PG port, PG user, PG database, and so on. And now you also have the PGRO for read-only. Like all of the PG flags now have a PGRO counterpart, which means that you can have two different database configurations, and one of them is used for the writes, which means the admin API whenever you make changes in the configuration, and the other ones are used for reading, which is essentially what the proxy path uses. So that allows you to spread the database load of your cluster across read-only replicas for better performance. So essentially, all of the database requests that happen through your proxy node, when proxying, you would hit only the read-only replicas, which are usually which will have generally less contention than the database nodes that do the writing, right? So so this is also a feature that's mainly designed for improving your performance for database users. And what makes Kong great is really the amount of plugins it has, which brings you the functionality that you put on top of a reverse proxy. So we have also been very busy at work making the plugins even better. So as it says in the slide, plugin improvements all around. They have many different things happening on various of them. So highlights are tons of new features for Zipkin. I believe Enrique is going to present some of them later as well. We've had new settings for rate limiting, including rate limiting by custom headers. We have Postgres auto cleanup in rate limiting. Lots of new features in Auth 2 as well. Persistent hash refresh tokens, PKCE, and hashing of secrets, and improvements in AWS Lamda, Prometheus, serverless in particular. Enrique is also going to demo that, because there's a really cool feature now, because you can essentially now within your Kong configuration, you can what the serverless functions, which are a pair of plugins called pre-function and post-function, what they allow you to do is essentially to make your own micro plugins without having to install anything. So you can write snippets of Lua code and put in your Kong configuration. And sometimes all you want to do is to issue this one PDK call, like the plugin development kit, which is essentially our SDK, our API for writing plugins. Right there in your configuration of your plugin, you can just write a snippet of Lua code and affect the request in some way. And now in Kong 2.1, you can actually affect any phase of the request lifetime, including processing the request, processing the response. So the possibilities for that one are truly endless. In previous versions, you were only allowed to affect the access phase, which is the incoming request. But now you can even do stuff with the response. So now essentially anything that you can do in a Kong plugin, practically you can do it with right there in your config. If you're using dplist, that would mean right there in your YAML declarative configuration as a snippet of Lua code. So now this is the power of those plugins has gone tenfold with Kong 2.1. Also more features on LDAP for virtual credentials that can be used as rate limiting criteria. So this interacts with the rate limiting plugins. And speaking of interactions between plugins, all of the various authentication plugins, they have now been standardized, and they emit the same credential identifier header. because some of them, like some of the plugins had used keys, some of the plugins used usernames. So they used to have like different headers, like they would say like X credential key, another one would send X credential username. Now they have a consistent header, so that this is useful. Like this was a user request because users wanted to make use in the client, like in their microservices, they want to know who, like what credential was, well, essentially who was authenticated, right? On the other side, if it was a user or another service. So regardless of how they logged in, because many services like Kong will allow you to have multiple authentication plugins configured. And so you can authenticate yourself and log into a service from different ways. And since Kong is the one taking care of the authentication, like the service itself shouldn't care about like whether they used key auth or they used some other basic auth or some other authentication, right? So with this standardized header, like essentially Kong allows you to abstract that in the client and leave the authentication 100% to Kong to take care. Another one of the highlights, it's an interesting one because it's something like very low level and internal, but it was a huge feat of engineering that we're very happy to have in Kong 2.1 is the support for dynamic upstream keep alive pools. What does that mean? The keep alive pools is the way that the connections are reused so that you don't go through the entire TCP and SSL and process of establishing a connection when you make multiple requests in sequence. Like this is key for performance. And one limitation in Nginx is that an upstream block, which is like a little block in the configuration file of Nginx, it has a limitation because the keep alive pool of Nginx upstream blocks do not, by default, like in vanilla Nginx, they do not account for the SNI and certificate, only for IP and port. So that means if you have multiple services that happens to be hosted in the same IP and port, but they serve, well, different services which have different SNIs or certificates, Nginx would get confused and might reuse an existing connection from the pool, right? And end up sending data to the wrong service, right? So essentially in Kong 2.1, we have our own dynamic upstream keep alive pools, which do account for IP, port, SNI, and certificate. So they will get it right, right? And it also, another feature coming from this, essentially like this customized patch that we have on top of our own Nginx that we ship in the core of Kong, is that it allows for an indefinite idle timeout and max requests for connections in the pool, which was a feature that used to be in Nginx, but for some reason was removed in Nginx 1.15.3. And essentially we put it back because it's a useful feature for our users. And there's a lot more. So as I mentioned earlier, as I said, I was going to put some pointers to the new stuff so that you can look it up in the documentation. So this is mostly what this slide is for. So it's like a collection of little odds and ends and things that were added. So for one, we have new attributes in the service entity to allow for per service customization of TLS verification parameters. These are the settings. You can look at them up in the documentation. We also have an important update in the declarative configuration format, which allow a YAML file of declarative config to specify whether the hashed attributes, for example, like their basic auth credentials, whether the keys are already hashed or not, right? Because sometimes you want to write down your keys and input them into Kong. So they are the plain text keys that you are writing and loading into Kong, for example, if you're importing. And sometimes you want the file to represent them in a hashed way. For example, when you are exporting from the DB, well, Kong only has the hash, right? It never stores the plain text one. So when it exports, it's already hashed. So what happens if you try to export something and then try to import back, right? That means like upon first import, the thing is not hashed, but when you're re-importing something that you exported, then it's hashed, right? So essentially there are two states that your file may be in, right? Already with the data transformation already performed or not. So now you can represent that in the Kong's declarative format. So for the first time, we have bumped the format version attribute. Since we have introduced declarative config in Kong 1.1, the format version was 1.1. So essentially that means that the format version entry in a Kong declarative config file is the lowest version of Kong that can understand that file, right? So Kong 2.1 still understands the 1.1 format, but of course it doesn't have the transform feature. But if you want to use the transform feature, you can specify format version 2.1, and then you can have this new option underscore transform, which can be true or false to indicate whether the transformations happen or not. So essentially what happens is that DB export will export the data already transformed, for example, the keys already hashed, and will indicate that in the flag so that when you import it back, everything works as expected. Some more features, we have been making improvements for hybrid mode. This, of course, is super useful for hybrid mode as well. This is used internally by hybrid mode. We also added support for a PKI in hybrid mode for improved security of the MTLS communication between the control plane and the data plane, and also for security between control plane and data plane. We have certificate expiry and CA constraint checks for the certificates that are used by hybrid mode. Also, since we've made like tons of improvements for plugins, as you have seen, like we have also been adding more stuff to the plugin development kit APIs. So here are the highlights of the things that are included. New mode for stream for TCP connections in Kong response exit, new method Kong response error for that makes it easier to send standardized errors instead of using exit. A whole new module for TLS client connection control, a new method Konglog serialize, which removed a lot of duplicated code from the logging plugins, and also Kong service set TLS verified methods. And if you want to get super technical, you can follow the changelog where we have links to all of the individual pull requests and essentially like go down to it, down even to the level of seeing the individual changes in the code of all of these new features. Finally, I would like to give a shout out and like give a spotlight for some of our community contributors who have contributed and shipped new features in Kong 2.1. Of course, this is not an exhaustive list of our community contributions because we get a lot of pull requests for bug fixes and that go into our patch releases. So those went in the various Kong 2.0.x releases. But these, I would like to highlight that these features that you see here on the slide were contributed by the community. So Abhishek Varshney contributed configurable consistency levels for Cassandra read and write operations. So these are also new flags that are available in Kong configuration. Eduardo Alonso contributed configurable negative TTL for cache objects. So now you have more fine-grained controls over your cache. Amber Heilman, she contributed several of those Auth 2 improvements, including PKC support, optional hashing of client secrets, ability to persist refresh tokens. And finally, Leandro Carneiro has contributed Prometheus health metrics and rate limiting by custom headers. Thank you all. You folks rule. If you're in the call or if you're not, well, I pinged everyone on GitHub as well to give them a shout out, and also in the blog post for the release announcement. And with that, I'm gonna hand over to Enrique, our systems engineer from the core team, for to go on with the demos. I'm gonna start sharing.
So can you guys hear me?
Yes.
All right. So let me get started by sharing my screen. The way I'm going to demo this first plugin, which is the new gRPC web plugin, is by talking a lot and not showing a lot of my console. This is because a lot of people are not familiar with gRPC, and even few of them are familiar with gRPC Web. So I'm going to explain what those are first quickly, and then the demo itself is going to be very short. I think that's better for most people, or most people attending this call anyway. So gRPC is a custom binary protocol that it's very efficient, but it tends to be used inside the same data center to communicate between microservices that belong to the same network. And because of this, it has problems when it needs to be exposed to the whole web. That's the reason why gRPC Web was developed. It's a way of providing a similar efficiency and speed on top of HTTP that makes it more friendly with firewalls and things like that you usually find in a corporate environment. So this means that if you want, you can use gRPC Web on your HTTP-based application, which tends to be JavaScript apps on browsers, to communicate with a server which is inside your firewall via gRPC. But your HTTP JavaScript application will have to use gRPC Web to do that. And between that and your server, you will need a translation layer, a gRPC Web to proper gRPC server that you will have to maintain and dimension, etc., etc. So what the proposal of value of this plugin is getting rid of that intermediate translation layer. Kong can take care of that for you. You just have to install this plugin and the requests will be translated automatically. In order to do that, you have to provide the requests with the proper content types, like this one or this one, because there are several encodings that you can use, and you can use plain HTTP, HTTP2, and SSL. So there are lots of combinations that we could test on this demo. But at the end, the problem with this is that, first of all, everything is binary, so you won't get to see a lot of intelligible text. Everything would be garbled. And on top of that, if we don't show the garbled text, all you see is an application that says everything works. So what I'm going to show you is instead the part that it's not gRPC Web, but it's also included on this plugin, which is right at the end here on this part of the README. In addition of all the content types that use gRPC Web, our plugin also supports plain JSON, which is very friendly for demos. So that's what I'm going to show you now. Apologies. Here it is. So I have 4 demos to show you. The first one is the gRPC Web one. And let me open my editor. I'm going to use Docker Compose for all of my presentations, and most of them are very simple. In this one, I have gRPC bin, which is a proper gRPC server that returns answers to some services it exposes. And I also will have a plain Kong DBLS with a configuration that I'm going to show you right now as well. Very simple. It has one service. It has a route and a plugin. The plugin is gRPC Web, and it points to a proto file. This proto file is here, and it describes the service that the gRPC server is serving. When I say gRPC server, I mean gRPC bin, this one. So it's a service that has several methods and a type of request and a type of response. And the demo itself is quite simple. It's taking this line here. Well, let me start everything up with Docker Compose up. Okay, Kong and the gRPC server are up. And then this is the request. I'm using HTTP PI. And this is a JSON request with a post method to, sorry, I'm trying to move zoom controls. Yeah. To this particular, let me try again. Oh, come on. Apologies. I'm having trouble with my mouse and zoom and everything. Yes, here it is. So this is a JSON request, a post request to this service on this method with these parameters. In using HTTP PI, that means that these parameters are part of the body of the post request. And this is the specific path that you have to use in order to invoke this gRPC service. As you can see, our plugin is now acting as a translator between a regular HTTP JSON-based call and a gRPC server without intermediate translation layer of any kind. So Kong is doing all the work. And of course, it's working because I see that when I post this name, I get the right response back. Hello is adding, the gRPC server is adding this part of the text to the answer, which is also being translated. And yes, this also works using the other protocols, the binary ones with gRPC web, but it all amounts to the same thing I'm doing here. It's a translation layer that it's working. So now I want us to consider the second approach, which is imagine that you don't want to use gRPC web. You are confident doing what I just did, but this particular format doesn't suit you for some reason. In that case, we have a second plugin for you, which is gRPC Gateway. Let me move to that one. I have to close this one down. Let me start it up. And let me close all the files here. So in this case, I have the same exact setup. By the way, I should mention that all of these files are online and available, and I will post a link. There is a link on the presentation for them, so you can use it later. The setup on this Docker Compose is the same as before. There is a gRPC bin and a Kong using DBLess. The configuration itself of Kong is a bit different. So let me open that one up. Here, in this case, I'm using the gRPC Gateway instead of the gRPC plugin, gRPC web plugin. And it's pointing to a proto file, but this one is a bit different from the other. It is similar, but this part is new. Here is where you can, using a custom language, you can encode the way these gRPC endpoints are presented to your HTTP side face, if you want. So basically, this means that you can customize the way your gRPC service looks from the outside, from HTTP. So let's demo this. Docker Compose is already up. And I forgot to open my demo cheat sheet. So this is the first one. I'm calling the I'm sending a get instead of a post, and using this custom format that I configured in the proto file. and I'm getting the answer back. And I can try the other variants as well. This one works. This is an alternative get method, but I can also use post. It works as well. So the main advantage of this plugin versus the other one is that you can customize. This is the other one for reference. And my advice or the rule of thumb would be, if you need to use gRPC Web, then of course use the gRPC Web plugin. It's going to help you a lot. However, if all you want is translating HTTP to and back from gRPC, then gRPC Gateway is a better option because it gives you this extra functionality, this extra syntax that you can use. One point to contest is, okay, so why does the gRPC Web expose any HTTP functionality at all? And the reason that is there is because sometimes you need one-off requests. And in that case, you can still use this, even if it's less convenient for your users than these ones. And that is all I had to say about gRPC. I don't know if we have any questions so far, because I'm going to move on to something completely different now. Hisham, do you happen to know if there is any question?
No questions in chat yet. If anyone wants to ask a question, like, feel free to use the chat. Or we have, yeah, or feel free to unmute yourself as well. Okay, here's a question.
Yeah.
The question is whether the .proto file can be embedded to the definition of the route.
No, the plugin itself can be embedded into a route, and then you can configure it with the proto file. Let me show you that. It's a good question.
Yes, to amend the question, like he meant the definition of the plugin, right, in the configuration, like where you put the proto and the file name, right?
Yes, both plugins work the same way. So I'm going to show you with gRPC Gateway. It's the same with gRPC Web. So if we go to the YML, you can see it right here. Notice that I'm on a service first, then I'm on a route, and then I add the plugin to that specific route. And that's where I link the proto file. So yes, you can link proto files to individual routes by replicating this kind of structure when you set up the plugin.
Let me ask you, so imagine that I'm using, I don't know, Kong in Kubernetes, and I don't want to create a config map to put my proto on it, then map to deployment to create a service mount to create the proto into my Kong container. So is it possible to put the definition of the proto in the YAML file?
No, that's not possible. I remember it was requested. I don't remember the exact reason why that is not possible, but I remember it was discussed and discarded. So I'll have to get back to you on why that is, but it was discussed and I remember it could not be done.
Okay, thank you.
Right. So let's move on. We leave the gRPC world and we move on to the serverless world. So serverless functions. The name of these plugins is a bit confusing, and I'm saying plugins on purpose. Serverless functions is in fact two different plugins. I'm going to demo one of them, which is the usual one. So let me start as usual, by opening the Docker Compose. In this case, we are not using gRPC anymore, but we need an upstream. And the one I'm using is, it says Kubernetes here, but it's just the one that Kubernetes uses for demos. I'm not using any Kubernetes related stuff on this demo apart from that. And below it, we have a regular Kong DBLess again, using a custom config that I'm going to show right now. Here it is. This is a bit more complex than the ones we saw before with gRPC. So notice first the name of the plugin that we are using. It's called pre-function. The serverless plugin, serverless functions plugin repo has two plugins inside, one called pre and one called post. The only difference between those are the priority of the plugins. So if you use pre, as I'm using here, this will run before most plugins. So if you want to do something before your authorization plugin kicks in, you have to use pre. However, if you want to do, on the other side, if you want to do something after everything has run, you can use post. In this case, I'm using pre because I want to run my own authentication code. Notice this part. I want you to concentrate on this part first. This is saying that on the access phase, I want to run this Lua code. And this Lua code is using the PDK, which is available. Everything called Kong.something is part of the PDK. And what this is implementing is a very simple authentication interface, which checks for a header to exist. And if it doesn't exist, it returns immediately and says invalid credentials. So let's test this out. I'm in serverless functions already. Let's up Docker Compose up. Okay, the echo server and Kong are running. And then, of course, I always forget this part. Here's my cheat sheet. This is a request using our custom authentication header. So since I added it, I got a 200. Let's look at the logs because there is something interesting here. First, there is this message, checking custom auth, which you can see here. That's the first line of this section of the text. But there are other lines. This one, for example, in pre-function access, you can see it right before that here. And that is one of the features of this plugin, which is that you can add more than one function per phase. The new addition is that you can add custom Lua code in all the Nginx phases. Before you were limited to the access phase, and now that has opened to also the header filter, body filter, and log phases, amongst others. The old format using this field called functions still works, but it's deprecated now. So yes, you can see that I'm also running the access, and header filter should be here, and body filter as well, and the log as well. Now let me run the same thing without authentication. Let's fail on purpose. I'm trying to fail on purpose, but I'm failing. Okay, now I got 401 and invalid credentials. So that's good. It's working as intended. Now let's see the logs. In this case, one important thing to notice is that the and the endpoint HTTP echo was not reached as it was on the successful request. So our plugin blocked the call. The other important thing to notice is that even if we early exited the function on the plugin, the rest of the functions in other phases of the request still run. So yes, we blocked the request, but the header filter function was invoked, and also the log function was invoked as well, as they were configured here. And that is all I have to say about this new plugin. Sorry, this new functionality of an existing plugin. So Hisham has kind of mentioned how to use this plugin, but I'm going to reiterate it again because it's very useful. Up until now, if you wanted to add a custom plugin that used a phase which was not access phase, you had to basically install a new plugin in Kong and restart Kong and everything. With this, you don't have to do any of that. You can store the Lua code that you want directly on the database or your YML config file. You can do tests, and when everything works, you can maybe transform that into a custom plugin, or just keep using the serverless functions plugin. And that is pretty much it for the serverless functions. No questions? Okay, so I'm going to continue with the last demo then. This is number 4, which is Zipkin. So quick intro for those of you who don't know what Zipkin is. Zipkin is a tracing server, and tracing can mean different things. In this case, it means that it's a kind of log service, but the logs have structure. The structure is called spans or trace. There are several concepts. I don't want to get this very in depth into that, but basically you will see how it's different from a regular log line in a second. Let me start by showing the Docker Compose as usual. And we have a little bit more complexity here. We have the same HTTP echo service as before, the Kubernetes one, but we are not using Kubernetes. Then we also have the Zipkin server. And finally, we have the regular usual Kong with a declarative config with DBLS. The configuration is quite small again. What we are doing is creating a service with a route and a plugin on that route, connecting. Sorry, the plugin is on the service, not on the route. I misspoke. And the plugin is connecting to the plugin, sorry, to the Zipkin server that is supposed to be instantiated by the Docker Compose. So let me start everything up. Okay, Eco server, Zipkin is in green, and Kong is in yellow, I think. So what kind of stuff can Zipkin show us? Let me show quickly. I'm going to generate some traffic using eco.dev, which is the name of our service in Kong. So I made 3 requests. They were accepted and returned by the echo server, which basically answers OK to anything you throw to it. And the interesting thing is what has happened on our Zipkin server now. Let me open it up. Zipkin has a nice web interface that we can see here. This is the Zipkin web interface. It's not showing any traces, but if I click here, it should show them. So here are the 3 requests I just invoked. I can click on them and get more information, of course. As you can see, this is not a regular log line. This is much more easier to work with, and you can also customize the way you select them directly on this interface with a bunch of information. Zipkin is mostly useful for detecting inconsistencies in timing. So if your requests are suddenly getting too slow for some reason, you can click here and start digging in to see, for example, how much time did the access phase of Kong take? How much time did the upstream take to respond after Kong sent his request? All of that. So it's a very convenient way of exploring your performance with Kong. The new features that we added was basically compatibility with latest versions of Zipkin and a bunch of small problems, like we fixed the way the data stamps were presented, which was not correct before. And we also changed the way these annotations are encoded according to what the Zipkin developers told us was best for Zipkin. And that is basically all I had to show you today. So I don't know if anyone has any final questions regarding Zipkin or anything else. Seems we are fine. So I don't know who's taking over now. Is it Hisham or is it Caitlin?
Hisham, anything else you wanted to say to close this out?
No, I think Enrique showed a lot of stuff, and yeah, there's a lot more. The slides have the link to the. Enrique, you're still sharing screen?
I know. I'm, as usual, trying to find the Zoom button so I can stop sharing. Apologies for that.
I wanted to share the screen to put on screen the link to your.
Yeah, here it is. I had to minimize everything. Apologies for this.
Yeah. So once again, here is Enrique's demo with the links to all of the resources to reproduce the demos and start playing with it. And yeah, I guess we get to the next slide with a pointer to Kong Nation, our forum. Date of our next call, and yeah, over to you, Caitlin. Anything else?
Yes. So if any of you have any more questions on 2.1 as you dive into some of these features, feel free to join us on Kong Nation, where we're happy to answer any questions. And then we will have our next online meetup coming up in August on the 11th. So we would love to see you all there. But again, thank you, Hisham and Enrique, for the great presentation, and thank you to everybody who joined us. And hopefully we will see you in August. Have a great day, everyone.
Yeah, see you guys.